This is day 8 of coding every day until I hit 1,000 subscribers. I was still jet lagged and working on other side projects, so I only made bug fixes to my code editor's audio. Over the next few days, I'll be back on a normal sleep schedule, so expect more project updates and longer videos. Spoiler alert for Leetcode 1358. Number of substrings containing all 3 characters. The problem asks us to find the number of substrings in a given string that contain at least one occurrence of each of the characters, and the string only contains these 3 characters. Here's my solution. I use an array called last_POS to keep track of the last seen index of each character, and it's initialized with -1. The total variable will accumulate the count of valid substrings. The code iterates through the string, updating the last_POS for the current character. The core logic is total plus equals 1 plus min last_POI. This adds 1 plus the minimum of the last positions to the total. So for each position, we find the earliest index where all 3 characters have appeared, which tells us how many valid substrings end at the current position. Finally, the total is returned. This solution has a time complexity of big O of n, because we iterate through the string once. The space complexity is big O of 1, because the last_POS array always has a fixed size of 3. Spoiler alert for Leetcode 3005. Count elements with maximum frequency. The problem asks us to find the total number of elements in an array that appear with the maximum frequency. For instance, if the most frequent number appears twice, and there are 2 numbers with that frequency, we return 4. Here's my solution. I initialize res and highest to 0. Then, I iterate through the unique elements in the nums array. For each unique number n, I count its occurrences using nums.countN. If this count is greater than the current highest frequency, I update res to this new count, and also update highest. If the count is equal to the highest frequency, I add the count to res. Finally, I return the res. This has big O of n time, and big O of n space complexity, since we use sets. That's all for today. Don't forget to like and subscribe, and if you have any ideas for projects you'd like to see me tackle in this series, let me know in the comments. You can also help me continue making videos by donating at buymeaboba.com, link in description.